So now let's look at some algorithms. These would be methods that we could use to add 2, 3, 4-digit numbers. So more than just our simple math facts of single digit numbers or maybe like 10 plus 2, more than just the facts that we would need to memorize. We're going to start what's called the standard algorithm. It's called the standard algorithm because this is what most people use to add these larger digit numbers. It is not the only method. It is not the best method. It just happens to be the most popular method. All of these are equally good, and our students learn differently. So we as teachers need to have different ways to explain things. We need to have different tools that our students can use because one tool might work for one student but not for another. So none of these are considered bad or not as good. They're just different from one another. And everyone thinks differently, so we need to have these different tools. So I'm just going to put up a problem here to get us started. So a 2-digit number. The standard algorithm is what we might call regrouping or carrying. So 8 plus 5 is 13. The 13, the 1 in 13, I put in the 10 spot, and the 3 down in the 1 spot. And the reason I can do this is kind of going back to the concept that we had for our expanded form. I think my pencil stopped working again, so let me do the little switcheroo here. So 13, I can think about in expanded form being 10 and 3. So that is a 1 in the 10 spot and a 3 in the 1 spot. Now I can add down the column of the tens. 1 plus 2 plus 1 is 4. So that gives me 43. What's called the expanded algorithm, or sometimes called the partial sums. Those are two different names for really the same process. Would work similar. So let me give us the same problem so we can kind of compare them. This way would not have that carrying or regrouping. So 8 plus 5, I could just write as 13. I wouldn't have to put that 1 on top of the tens. Then I would go to add down the 10 spot, and I would have to think about that as being 20 plus 10. Or we can think about it being 2 plus 1, but I do have to put that 3 in the 10 spot. So 20 plus 10 is 30. And then add again. So I get 43. Both of these, about the same amount of work. For the first one, the standard algorithm, we split that 13 up, which might be hard for some students to understand. And the second one, we do have to add twice there. So pros and cons both times. Next, we've got the left to right algorithm. So it's pretty much just like what we did before, but we're going to be starting on the left-hand side. This makes a little bit of sense since most things we read left to right. Not all things, but a lot of things. So I'm just going to give us another problem to show that all these algorithms could be used with 2-digit, 3-digit, 4-digit. Doesn't matter how many digits, as many as we would want. So for this one, I would start over in the 100 spot. 400 plus 600. Is what that says. 400 plus 600 is 1,000. So I would write 1,000. Then I would add the 10 spots. 80 plus 90 is 170. I didn't give myself very much room. And then the 1 spot. 6 plus 2 is 8. So I'll just put that in the 1 spot. And then adding down, I'm going to have to kind of squish it over there. 1,178. Now this last one, the lattice, gets a bad rap. It's not any more different than the other ones that we just did up above, but for some reason people love to pick on lattice. Lattice addition isn't as popular as lattice multiplication, but lattice multiplication is pretty popular. I see students all the time that this is exactly how they multiply by hand. Like I said, adding I don't see quite as much, but still it is out there and is pretty much widely used, probably more so than the left to right algorithm for sure. So again, I'll show we can use any of these algorithms will work with any amount of digits. So I'll just go on up. We're going to increase our digits and have a 4-digit number. Now, most of the time it is easier. This is called a horizontal addition expression here. It is easier most of the time to go ahead and write, no matter which of these algorithms we use, in the vertical form. So I am going to do that. There are plenty of places online that you can print off lattice grids for the students to use, both for addition and for multiplication. So what we do with the grid is we're going to set it up here so you learn how to set it up. Like I said, you can go online and print out these, but you're just going to draw a box underneath each place value. So there are 4 place values, ones, tens, hundreds, and thousands, so 4 of these boxes. And then we come along and we make, this is the lattice. Lattice refers to a patterning. You might see a lattice fence work. That's where it's used a lot, but that diagonal there. So you make a box and then a diagonal in each box. All right, now we're going to add. It doesn't really matter the order that you add. You can start on the left or right. That's the good thing about lattice. I'll start on the right because that's normally how people start, but again, left or right works for lattice. 6 plus 9 is 15. 7 plus 8 also is 15. 0 plus 6 is 0. 0 plus 6 is 6. You can put a 0 in the top space or leave it blank, but the 6 has to go down below in the lower spot. And then 9 plus 4 is 13. So what we've done is we've added each one of these up separately in its little box. Now, the lattice part says I'm going to add across the diagonals, and I haven't drawn these super even. So I'm going to add just in between these diagonals what I have as my blue lines. So for this first one, it's just the number 5. For this next one, I'll try to highlight it. It's all the numbers between those 2 diagonals, so that gives me 6. Then it's going to be all the numbers between the next 2 diagonals, so that gives me 7. Then all the numbers between the next 2 diagonals, so that gives me 3. And then, I don't know, we'll see if that one, all the numbers, there we go, between those diagonals, so that gives me 1. So my answer would be 13,765. Feel free to rewatch this, rewind, and watch it again. You also can go to YouTube and type in lattice addition. Make sure it's addition. We'll do multiplication later. And you can see more examples of that. But real quick, if you need to rewind or go check that out, that's fine. But I also have a problem for you guys to try on the next page. It's at the end. So I would like for you to try this once you feel comfortable. Once you feel comfortable, hit pause and give this one a shot. All right, coming back from pause, let's see how you guys did. So we're going to set it up. There's going to be 1, 2, 3, 4 boxes, and then we're going to put the diagonal in each one. If you haven't tried it, if you didn't hit pause and try it, or didn't go rewatch the video, rewind it, watch some videos on YouTube, now that I've got it set up, really do it. Try to add the, to go ahead and do the lattice addition since I already have it set up for us. All right, 6 plus 5 is 11. 8 plus 3 is also 11. 5 plus 2 is 7. And 4 plus 7 is also 11. I was really big on 11. Now I'm going to add in between these diagonals. So for this first one, I just get 1. For this second one, I'm going to get 2. For the third one, I would get 8. Oops. For this fourth one, oh, my pencil stopped working again. Let me go back, get my pencil going. For this fourth one, I would get 2. And for this last one, would just be 1. Oops, I'm sorry. I would not get 2 for that one. That's my fault. I would get 1. 1 plus 0 is 1. That is my fault. on there. Sorry about that. So I would get 11,821 for this answer.